Good morning, afternoon, or evening. Welcome back to Mr. Morrow's algebra class. Today we are going to continue with exponents, but we're going to take it to an application part of the exponents. Exponents are extremely powerful, and a lot of times my students tell me, what is this used for? How do we use this in real life? Well, today I'm going to show you how we use this and where we use it in real life. Whenever we're working with extremely large or extremely small numbers, okay, you're going to use powers of 10, okay, in order to represent decimal movement. What am I talking about? When I have a number like, let's say, the distance from the sun, from Earth to the sun, I believe it's 93 million miles. It may be 930 million, but let's just say that it's 93 million miles. Okay? What do these zeros represent? Powers of 10, correct? So I can rewrite this number so that it could be 9.3 times 10 to the 7th power. This power of 10 here tells the reader, hey, dude or dudette, move the decimal this many places to the right or this many places to the left. That's what's going to tell you how to move your decimals. So when you got big, large numbers like this, with all due respect, isn't this a lot easier to work with than this, my friends? Right? So this has a use. Who uses it? Engineers, physicists, astronauts, the team that works in NASA, the people that create the Mars Land Rover, people that create missiles. A lot of different applications here, okay? When you're working with very large or very small numbers, we're going to use scientific notation. And again, it's a way of writing large numbers or small numbers using powers of 10. I'm going to show you how all of this works, I promise. I just wanted to give you a visual real quick so you can understand what I'm talking about now. When you have a positive exponent, the positive exponent, I'm talking about the exponent attached to the 10, to the base of 10. When you have a positive exponent, okay, those are used when the original numbers in absolute value that are greater than 1. Let me see. Hold on. All right, there you go. It's better lined up. Okay. When you have an original number that's larger than 1, when you're converting that to scientific notation, please remember this. You're always going to use positive exponents for x. Most teachers like to teach it when you're going to the left with the decimal, you have a positive exponent. When you're going to the right with the decimal, you have a negative exponent. But then, when we're going from scientific notation to standard form, it reverses. If you have a positive exponent, you go to the right. If you have a negative exponent, you go to the left. So when I was a kid, I always had a big confusion. You know, I'm human. I would say to myself, oh my God, okay, wait. Did I go to the right? Is that positive? Is it left when I go negative? I didn't know. So I came up with a little system that works 100% of the time, okay? And it's this right here that I just told you. If you look at your original number, if your original number in absolute value, it doesn't matter if it's positive or negative, we're looking at the absolute value of the number. If that number is greater than 1, you're going to have positive exponents. And I'll explain all of this with examples. Negative exponents are used for original numbers in absolute value that are greater than 0 but less than 1. In other words, they're a decimal value, okay? It's a fractional or decimal value. Okay? Now, let's do it. Best way to learn is by doing it. There's 3 things we're going to learn today. First thing is converting a number in standard form. Standard form is just a regular number. To scientific notation. First thing you're going to do whenever you see the number, regardless of if it's greater than 1 or if it's a decimal value, you're going to make the value of the given number a value between 1 and 10. So I don't care how large the number is or how small it is. You're going to move the decimal places, either left or right, to make that number a value between 1 and 10 by moving decimals left or right. If you are moving the decimals to the right, that means that you're working with decimal values which are less than 1, so you would have negative exponents. If you are moving the decimals to the left, that means you are working with values that are larger than 1, so you must use positive exponents. This whole left and right thing, I actually hate it. So I'm going to teach you what I taught myself when I was a kid, and I never got these wrong ever again. Are you ready? I'm going to just blow you away here. First of all, is this number, the original number, is it larger than 1 or less than 1? So I'm going to use a positive exponent. You with me? That's half the battle. Now, where is the decimal of this number? Where do I have to move this decimal to make this value a value between 1 and 10? 1, 2, 3, 4. You see that? I have 4 to the left. So this is going to be 2.23 times 10 to the 4th power. Done. That's scientific notation. Why did you use a positive power, Moro? Because the original number was larger than 1. Does that make sense? B. Okay, it's negative. That negative does not affect the exponent. Remember that when we're dealing with whether or not we have a positive or negative exponent, we're looking at the absolute value. So the absolute value of this number, is that greater than 1 or less than 1? So we're going to have a positive again. 1, 2, 3, 4, 5, 6 places to the left. So it's going to be negative 1.25 times 10 to the 6th. Why did we use a positive exponent, Moro? Because the original number was larger than 1. Does that make sense so far? Pretty easy, right? And this way you don't have to remember left, right, up, down, sideways. You don't have to remember any of that. You just use your brain. Now this number. Give me 1 second, please. Okay, sorry about that. Back to work. Now, I got 0.0023. Wait a second. Is this number larger than 1 or is it less than 1? It's less than 1. You know, the absolute value. We never we don't worry about the negative part. That doesn't make a difference. It's the absolute value. So I'm going to use negative exponents. Make this number a value between 1 and 10. 1, 2, 3 to the right. 2.3 times 10 to the negative 3. Done. D, 0.035. Is that larger than 1 or less than 1? So I'm going to use a negative exponent. 1, 2 to the right. 3.5 times 10 to the negative 2. For those of you who has done scientific notation before, do you understand it now? Did you understand it last time you learned it? This is clearer, right? That's what I thought. I always had a problem with this because of the left and the right. But when I figured out, wait a second, dude, look at it logically. I love it. So again, larger than 1, positive exponents. If it's a decimal value that's less than 1, negative exponents. Second skill. This one's really simple. Converting from scientific notation to a number in standard form. This is a piece of cake, guys. This one is straight up easy. When a number is written in scientific notation and has positive exponents attached to the base of 10, simply move the decimal of the number shown to the right as many places as there are exponents. That makes sense. Positive numbers, we usually go to the right, correct? Is that on the right side of the number line? Okay. When the number written in scientific notation has a negative exponent attached to the base of 10, Simply move the decimal of the number shown to the left as many places as there are exponents. Fill in the gaps with zeros. Literally, this is the really easy part. Let me expand these just a little bit because, hold on, let me get this out of the way for a second. Let me make these a little larger. Okay. All right. Rock and roll. Okay, so I got 8.3 times 10 to the 5th power. Write your 8.3. Am I going to go to the right or the left? 1, 2, 3, 4, 5. Be neat and end with an arrow so that you know which way you went and you know where your decimal goes now. You with me? Fill in the gaps with zeros. Now, rewrite it. That's the important part. Rewriting it so that it's nice and legible, clear, and neat. 4.2 times 10 to the negative 4. Do I go to the right or to the left? Okay, so I'm going to go 1, 2, 3, 4 to the left. I put my arrow because that's where my decimal is, and I fill in the gaps. Now I clean it up. Put 0, 0, 0, 4, 2. Make it nice and neat and understandable. 3.75 times 10 to the negative 6. Right or left? Left. 1, 2, 3, 4, 5, 6. Place my arrow, put my decimal there. That's where the arrow goes. My decimal goes 1, 2, 3, 4, 5. Fill in the gaps. Clean it up. 1, 2, 3, 4, 5 zeros. 3, 7, 5. 6.5 times 10 to the 3. Right or left? 1, 2, 3 to the right. Put my arrow so you know where your decimal went. Fill in the gaps. Clean it up so it's nice, neat, organized, and clear. Mickey Mouse, right, guys? Okay, now, don't stress. Everyone stresses on the next part, but it's easy, okay? I promise you. My friends, we're going to sometimes have to multiply or divide numbers in scientific notation. First thing you want to do, multiply or divide the numerical values. The numbers, multiply them or divide them by themselves first. Second, multiply or divide the bases of 10. Remember to use the law of exponents. Remember that when you multiply the same base, you add the exponents. Remember that when you divide the same base, you subtract the exponents. And then finally, here's the part that kills a lot of people. Write the product or quotient in proper scientific notation. Proper scientific notation means that the numerical value must lie between 1 and 10. Thank you. Good job. Good job. Does that make sense so far, the rules? Let's put it to play, okay? Trust me. Don't stress. First thing we do, number times number. What's 3 times 8, my brothers? 24. Times 10 to the 9th. Now, is this in scientific notation? No. Because this number has to be a value between 1 and 10. Everyone's with me? Okay. Stop writing for 1 second and just watch. In order to make this scientific notation proper, I got to move this decimal once to the left, right? So that becomes 2.4, right? Now, here's the trick. Was this number larger than 1 or less than 1? So am I going to add an exponent to 9 or subtract an exponent from 9? Add. So I got times 10 to the 10th. That's what kills people. That's why my trick is so awesome. Because you knew that 24 was larger than 1. So I'm going to have to add exponents. I went 1 to the left. That's 2.4 times 10 to the 10th now. I had the 9 plus the 1 that I moved. I got 10. That makes sense? Thank you, my brothers. Now, Remember the trick that we use, guys, for dividing exponents, how I said just cancel them out, it's easier? You cannot use that here, okay? Here you're going to have to use the official way to do it, but it's easy. What's 115 divided by 0.3? Okay, 1 to the right, 1 to the right, and that's 50. So that's 50 times, okay, let's look at this. Isn't that 10 to the negative 6 minus 4? Isn't that what we do? So this is 10 to the negative 10th. Now, is that in proper scientific notation? No. So pay attention. I got to move the decimal 1 to the left, correct? Am I going to add an exponent or subtract an exponent? So I got 5.0 times 10 to the negative 9th. Is this making sense, guys? This is the hardest part. So if you got this, you're done. Does that make sense? Okay, awesome. 240 divided by negative 3 is 80. Thank you, negative 80. Times 10 to the, remember this is 10 to the 8th minus 15th. Thank you. 10 to the negative 7th. You guys with me here? Is that in proper scientific notation? So I got to move the decimal 1 to the left. Do I add to the exponent or subtract? So I got negative 8 times 10 to the negative 6. You with me? Okay. Now, just because I want to show you a little bit of a different one, please go ahead and make that a 0.12 and a 0.11, please. Please go ahead and make that a 0.12 and a 0.11, please. 11 times 12 is 132, right? But with 4 decimals, it's going to be 0.0132 times 10 to the negative 4th. Does everyone see that? Promise? Promise? Okay. Now, is that in scientific notation? No. Pay attention. Is this number less than 1 or greater than 1? So am I going to add exponents or subtract? Ah, perfect, guys. So I go 1, 2 to the right. So I got 1.32 times 10 to the negative 6. Because I had to subtract 2 exponents. And ding dong, the witch is gone. Thank you very much. I hope you learned a lot and have a wonderful day.